Alright, this is a demonstration of a game called Nim that I've developed. And so the basics of the game is you will have 3 rows of LEDs. So as you see, we have the first row 3 LEDs, second row 5 LEDs, red LEDs, and the last row is consisting of 7 green LEDs. Now the whole point of the game is the last person who turns off the last LED loses. So basic rules of the game: you have 2 players. Each player there's a button for each row, and there's 6 buttons in total, 2 for each row, 1 for each player. So for example, say I'm playing as the first player, I would press 1 time to turn off 1 LED. If I press it again, I can turn off 2 LEDs. The whole basic rule is I cannot turn off LEDs from any other row, just like the basic rules of Nim. So as we see, then unless the other player, for example, goes and turns off a couple of other LEDs, then I'm allowed to turn off from my side. So this is just pretty much basic rules for the actual game, and now we'll go with the specifications of the actual software and hardware. So first of all, I'm using the LPC Espresso, the 1769 chip, and as we can see, this is pretty much just a basic schematic of the circuitry. So as we said, so we're gonna have those LEDs are the green, the blue, the red, connected to our ports with their specified bits, and then you will have, so this is really quick, so that's your LPC 1769, and say for example we're using for first button, let's just for demonstration, so port 0 bit 6. So we have an LED, and we're using 110 ohms for the green and the red LEDs, and around 160 ohms for the blue LEDs. And then this is your VCC, which is around 3.3 volts. So whenever this port is low, this LED will go on, and when this port goes high, the LED will go off. So what we have is, we have you have your momentary button. This is 1K resistor going to VCC. This is one side of the, and then this is going to ground. So the button is set to high, and once it's pressed, it goes to ground. So it reads right here, it reads 0, outputting a 1 right here, causing the LED to go off, and so forth. So as we can see, first we declared all our pins, we declared our inputs, our outputs, set up the direction for them, and then once that on, we set all our LEDs to low in order to have them all on. Then we created a buffer. Since we have 3 rows, we're actually using 3 bytes. So each row is 1 byte. So at the first byte, we're actually just using 3 bits. Second byte, we're using 5 bits. And the last byte, we're using 7 bits. And what happens is, we have a buffer that updates every time you press a button. So for example, whenever I press the first button, each button has a declared state. So you'll have let's just call it first button state, second button state, and so forth. So whenever button state 1 updates, what happens is you're gonna have an increment, 1 bit increment. You're gonna have a bit shift. So for example, first row, Okay, so say that's our first row. As we can see, we have those 3 bits high and those are low. So when we press a button, what happens is you're actually shifting to the left by 1 bit, causing one LED to go off. Press that button again and it updates the buffer, incrementing it again by 1, turning the LED off. And that's just how it goes. Now, to ensure that you cannot cheat, as in you cannot turn off LEDs from multiple rows in one turn, we actually defined a global variable. So you have, say for example, actually let's look here. So you have player 1, say for example player 1, row 1, button pressed. So player 1 right here, button 1 is being pressed. Once that is pressed, then set those to do nothing, as if even if those are changed, the state, the button status, say button 1 status, button 2 status, even if it changes, it does nothing. It does not actually update the buffer unless one of those LEDs are pressed, and that's just how it goes. Pardon me. So, and that's just pretty much how it goes. And in the end, so for example, let's see. Okay, I finished my turn. Okay, this guy finished his turn. So what happens now, once all LEDs are off, it's gonna wait close to 2 milliseconds. We just have a simple wait function in the end that once all LEDs go off, just return to the initial state where they all go on back again, and then you can play again. See, all rules are enforced, and that's just how it goes. If you'd like to check out the source code, or you'd like the schematics for the circuitry, just inbox me and I'll try to get in touch with you, and feel free to ask for any information.